Okay, so we're going to pick up on this problem. So we said we identify polygons that have reflection symmetry, and we identify polygons that have rotation symmetry. So what about the last one, translation? So remember, translation is that slide. Oops. Is the slide. There we go. So it's going to how can we like move something up? So is there any polygon that can be translated, so moved up, down, left, or right, so that it ends result is exactly where the same object is? So again, if we take a look at all of our pictures, right? So again, can I take this picture and slide it up and it will be exactly on the same image? And again, I can slide it up, down, left, or right, but I have to take the whole image. Do you think that there is any one of these pictures that is going to have this? And the answer is no. None of these pictures are going to have translation symmetry, which is fine. They just have rotation and reflection. Okay, so, but can you think of any shape that we've talked about or figure that can have that translation symmetry? There's one shape that I can think of that you have graphed. And if you can't think of it, I'll give you a hint. You have to draw it on an X and Y axes. Can you think of it now? Hopefully the answer is yes, and it is a line. All right, lines have translation symmetry. So what you can do is you can take this line at any part of it, and then, so say I just take this section of this line, I can slide it up and I can slide it over, right, and it's going to land perfectly exactly onto the same one. Okay, so lines are a shape that actually have translation symmetry. So when we think about translation symmetry, sometimes we actually talk about it in terms of graphs that we're going to see. Okay, so again, let's describe some symmetries. So all types of symmetry for a given polygon. So here's our polygon. This is an example of a 10-sided polygon, aka a decagon. So again, it's a regular decagon, which means that all of these sides are going to be equal to each other. So I want you to go ahead and I want you to pause the video and I want you to try to answer A, B, and C's question in regards to this decagon. And I'm going to go ahead and help you erase it, these lines, so that way we know that, that if you want to trace this from your computer. All right. So what kind of reflections can this decagon reflect onto itself? So does it basically have reflection symmetry? Yes, it does. It has reflection symmetry. Now we want to describe the lines of reflection. Okay, this is going to, the best way I can tell you to do that is that these points right here, right, all of these points right here, right, are called vertices. Right? It's where two lines kind of meet, and you actually have 9 of them. So there's 9 all the way around, right? So you have 9 vertices. And if you draw a line through your vertices to the midpoint, so let's pretend that this is the midpoint. So if you draw a line from this to your midpoint right across, from the opposite side of the polygon, you will then have reflection symmetry. So if you have 9 vertices, that means you have 9 midpoints. Sorry, not 9, 10 vertices. I was thinking a nonagon, so I apologize. This is a decagon, so there should be 10 vertices, which means that there are 10 midpoints. And if there are 10 vertices and 10 midpoints, that means that there are 10 ways to do this. So how many lines of reflection? You are going to have 10 lines. And that's why on this hexagon, we have 1, 2, 3, 4, 5, 6 lines, which means we have 6 lines of symmetry. 5 lines here, so 5 lines of reflection symmetry. Can this be rotated onto itself, right? The answer is yes. It does have rotation symmetry, which is very nice. Okay, so if we actually think about your rotation symmetry, right, just like on this previous problem, if I divided 3 sides by 360, and I got 120. On this one, there are 10 sides. I'm going to divide 10 into 360, and I'm going to be left with 36 degrees. Now, you might not know what 36 degrees is when you're rotating it, but every time that this vertice moves to here or here, you're going to rotate it 10 times. It will be 36 degrees each time. So that's what it means by does it have rotational symmetry and things like that. Does this have translation symmetry? And the answer is no. There's no way I can copy this picture, slide it up and over, and it land perfectly onto itself, unlike the line on the last problem. So no, it has no translation symmetry. I can't translate it. I can't slide it. So one last thing that I want to show are these graphs, right? So I want you to kind of, again, pause the video, see which ones have reflection symmetry, rotation symmetry, and see now if any of these do have translation symmetry or a combo of them. So go ahead, pause the video now. All right, so coming back from the pause video, number 1. So number 1, again, these are a little bit more challenging to see, but this one is going to have all 3. It will have rotation symmetry. So if I rotate it around, say, a point, this will rotate up here and this will rotate down here. So it does have rotation symmetry, and it does have reflection symmetry. Okay, so I can see my reflection in here. This one was probably a little bit harder to see, and most importantly, translation. So we can actually see the translation on this one. Okay. On number 2 does not have a translation, so I can't take my whole graph and then move it up and over, right? So it does not have translation. It does not have rotation. Actually, the only one it does have is reflection. And this one is actually over the y-axis. So I will be able to reflect this piece, and it will land perfectly onto this piece. All right, number 3, right? This one does have a rotational symmetry. So say I rotate it around the origin. This piece would come down here. This piece would come up here. So it does have rotational. Okay. It is going to also have, it doesn't have reflection, so I'm not going to be able to reflect it up or down. Okay. But it does have translation. So I'll be able to take my graph and then I can slide it this way and it will land perfectly onto the other one. All right, number 4, rotational symmetry, it does have. So I should be able, again, I can rotate it. This piece will come up here and this piece will come down here. So it does have rotational. And it does have reflection. So it's reflecting kind of over your origin. So it's kind of reflecting down below. So it does have reflection. Okay, and then last but not least, it does not have translation. So there's no way that I can move this up and over and it land perfectly on itself. Okay, number 5. So this lovely, weird looking graph. It does have rotational symmetry. So I should be able to rotate my graph and it should land onto itself. Okay. It does not, unfortunately, have reflection symmetry, so there's no way I can reflect it up and over or down and over an x-axis, y-axis, or a random point. So it does not have reflection symmetry, but this does have translation. So I should be able to copy this and then move it up and then over, and it will land perfectly onto itself. Okay, last but not least, number 6, right? Does this have rotational symmetry? No, it does not. I should not be able to rotate it and land it perfectly back onto itself. Reflection symmetry, it does have. So reflection symmetry, very similar to number 2, right? It is over that y-axis right here. So this piece and this piece will land perfectly onto itself. This is known as an absolute value graph. This one is your quadratic, FYI. And this one does not have translation. So again, it's important to be able to recognize these types of symmetries when we're dealing with graphs, and be able to recognize, does it have a reflection, rotation, or translation symmetry.